And so begins the exponent units. So first thing we're going to do for one day is review the exponents that we did back on the second and third day of school. So there are 3 laws of exponents, and that's it. The 3 laws of exponents are, well, first you have to realize that you have a base and an exponent. Bases and exponents, it's very important you realize the difference. So when you have a base, here, for example, x is a base, x is a base. When you're multiplying the bases, you add the exponents if the variable's the same. Okay? So remember, it's like x squared times x cubed, 2 plus 3 is 5. And that's because it's x times x, and then there's 3 of them, and altogether I have 5. The next one, when you're dividing, same idea. You're dividing the bases. When you divide a base, like x to the 5th divided by x to the 3rd, you have 5 on the top, 3 on the bottom, so we're left with only 2 left. So those are dividing exponents. You subtract. And then finally, when it's a power to a power, you multiply. Okay, because, for example, x squared to the 3rd power, that was the same as x squared times x squared times x squared, which is this rule. So that's x to the 6th. Only way I can think to help you remember, because it's killing me that you can't remember, is how when you're here, when there's a number right next to, and that's just regular multiplying, you distribute. Well, when there's a parenthesis right next to a exponent, you multiply the exponents, just like you would multiply here. I can't think of another way. If you can, let me know. Okay, try it yourself. So take a second and try these. Okay, I am going to go through them in just a second. Okay, so notice you're multiplying bases. Those tens, here there are 5 tens, here there are 4 tens, so on the top altogether you're going to have 9 of them. Sorry, on the bottom you only have 6. So on the top you have 10 nines, on the bottom you have 6, so what you're left over with is 10 to the 3rd, or 1,000 if we're going to get specific. Okay, so be careful when they are numbers. The tendency is to make that like 100 x to the 9th, which it's not. Remember, this is 10 fives, 5 tens. I got that. 2, 3, 4, 5, and then 4 tens. Altogether, I still have 9 of them. 9 tens. Okay, so be careful with that. When we have a question like this, number 2, I like to give everything an exponent that doesn't have one. Okay, because the problem is these parentheses here means I'm going to multiply exponents, not numbers, exponents. So it's 2 to the 5th, x to the 5th, and there's nothing going on here. Okay, and then same deal here. 5 minus, you're dividing, so it's 2 to the 4th, 5 minus 3, x squared. You should figure out what the answer to numbers are. So that's 16, x squared. You can always just do the numbers, in a calculator, or just multiply them. So this is 3 to the 4th and 3 to the 8th. So when you multiply the bases, you simply add the exponents. Okay, 10 to the 3rd, again, the bases are the same, so you subtract the exponents. Don't get all confundled because the x to 10s aren't x's or whatever. They're still a base. That's all you can do. Okay? So up here, same deal. These things don't have exponents. The 4 doesn't, so I'm going to do that and multiply the exponents. So it's 4 squared, multiply 2 times b, and 4 squared is 16. I don't know where the x came from. Some crazy world. Okay, down here, number 6. 2c times 2c. Well, The bases are the same. You're multiplying the bases so that you add the exponents. Remember, c plus c is 2c. Divide that by 2 to the 2c. Look, anything divided by itself is 1. Okay. And number 7, 3 to the 1st, 3 to the 7th. So that's 3 to the 8th. And I'm not going to figure that out, but I'm sure it's a number that's really big. Okay, same deal. You just have to know your exponent rules. You're multiplying the bases on the first one, so you add the exponents. Okay, there's an issue sometimes with adding. I don't know why, it just happens. When I add these exponents, I get 6x minus 4, so that's the new exponent. Okay, just be careful of that. Make sure you're adding correctly, combining like terms still. You're still adding. Okay, so you multiply the exponents together, so it's 5 squared, a to the 4th, b to the 6th, 25, a to the 4th, b to the 6th. And over here, we're subtracting, we're dividing. These are bases, and this sign means divide. So let's divide. When you divide, you subtract the exponents. So it's 2c plus 4, and I'm subtracting this, so minus c minus 2. So remember, when we subtract 2c plus 4, I change, this is how I do it. Okay, change your sign, distribute that negative through, keep change, whatever, however you want to think about it, that's the way it is. So it's c plus 6. Or 6 plus c, sorry. I don't know why I wrote it like that. Okay. Down here, there's a couple rules you have to follow, so we have to follow them, however we want to. In this case, you can do whatever you want to first. Sometimes it's easy to distribute this 2 first. Sometimes it's easier to simplify here first. It's whatever you want to do. As long as you math correctly, you can do this. So just math correctly. Some ways are easier than others. I'm just going to distribute. That's the way I feel. So when you distribute to all exponents. So 4 squared, x to the 8a, 3 squared, x to the 4a. So these guys are numbers. It's 16 over 9. Can't really do much with that. This is division, and these are the same bases, so I just subtract them. So remember, whenever I subtract, the answer always goes on top. And there's really nothing else I can do. There's no reducing. So hopefully you remember these exponent rules and you're not too confused. Have a good day. So here's a short video about the 0 power. Anything to 0 power is 1. We did go through this back in the day, but let's just do it again. So anything divided by itself is 1. This is x to the 5th, that's x to the 5th. It's the same. But if I follow my exponent rules, 5 minus 5 is 0. So that's really why. And the most deep thing I'm going to show you there. Okay, find the value of each expression. So the basic idea is you have to really pay attention to what the 0 power is being raised to. So if there's a parenthesis, it's being raised, the whole thing is being raised. If there is no parenthesis, it's just what it's attached to, what it's closest to. So in this case, the 4 isn't connected. So here we go. 7 to the 0 power, well, there's only 7 there, so that's 1. This is negative 4 to the 0 power. So it's negative. It's basically saying negative 1 times 4 to the 0 power. So it's negative 1 times 1. It's negative 1. So that 0 is not raising that negative. That's the weirdest one to see, but you have to just remember that. This whole thing is being raised to the 0 power. Just the x is being raised to the 0 power. So that's 4 times 1, or 4. Remember, x to the 0 is that 1. This whole thing is being raised to the 0. Okay, in this case, 3 times x to the 0 power, only the x is being raised, in this case the whole thing. So it's 3 times 1 over 1, which is just 3. So hopefully that's one of the biggest things. If you can determine what is being raised to that power, and not just assume it's everything that it's near, it makes life a lot easier. All right, have fun. All right, here we have negative exponents. It's another way to write the base as a fraction. Huh? Well, okay, so here it goes. If I were to reduce this, you have 3 x's. Here you have 5 x's. These cancel out. I'm left with 1 over x squared. Yes? If I rewrite it using my laws of exponents, I divide here, I'm left with x to the negative 2. Remember, it's x, the first one, the top one, minus the bottom one. So x to the negative 2 power is the same as that guy. So it allows us to write fractions without fractions, for the most part. And it allows us to move things with exponents to different parts. Okay, so there's 2 parts to every term. Every term has a top, and every term has a bottom. You know, like if I have 2, I put it over 1, and it's a fraction. So everything can be written as a fraction. And it simply means, if I have a negative exponent, it simply means that wherever you are, that base, whatever the exponent is being raised to, is in the wrong place. So if it was in the top, it moves down. If it's the bottom, it moves up. Okay, that's it. This is interesting, good stuff, so read it. So here we are. The biggest thing you're going to want to remember is what is it being raised to? Okay, what is being raised to? All the fun. So here a can be written as a fraction. So that's what I do. Now that negative 6 means that a is in the wrong place. So that a should be down here. But it needs to take the 6 with it, and when it moves it now to the right place, it's now in the denominator. And that 1 I need as a placeholder. There's no choice there. Okay, that's it. So it's in the top. If it's negative, it's in the wrong place, so it moves to the bottom. Now here we go. Y to the negative 8th power. That's the only thing being raised to the negative 8th power. So if I write this thing as a fraction, this negative 5 is going to stay where it is because it doesn't have a negative exponent. It stays. But that y to the 8th moves down. Now it's in the right place, so it's positive. So here, this whole mess, not the negative, is being raised to the negative 2 power. So when I make this as a fraction, the negative stays up here. Though we know that's kind of inconsequential. The 2x moves down, and the exponent is now positive. Same deal here. This is already a fraction, but that x to the negative 7th is in the wrong place. It's in the bottom here. So let's move it to the top. I don't need the 1 down here, or anything down there, because x to the 7th is the same as x to the 7th over 1. So here's some more, and more rules, and we can do, you know, just more fun, if we like to say. So what we want to do is simplify these and make it so that they don't have any negative exponents. So again, if you're doing math and you're doing it right, you're good. Okay, so this is negative x to the negative 5th power. So I like to think of this as negative 1 to the 1st. So if we do this, I'm just going to read negative 1 to the 1st, x to the 1st, and this whole thing is being raised to the 5th. I didn't need these parentheses. I was just being silly. So just remember, distribute the exponent. So it's negative 1 to the 5th power, x to the 5th power, or negative 5th, excuse me, over x to the negative 3rd. Okay, so we're going to just do the math here. Negative 1 to the negative 5th power. Well, you can do that with your calculator. That's pretty straightforward. It's just negative 1. All right, here we're dividing. When you divide, you subtract your exponents. So do that. Do negative 5 minus a negative 3. Hopefully you got x to the negative 2 power. Now if this is what I do. I do all my math, and then I deal with my negative exponents at the end. If you don't want to do that, you want to deal with your negative exponents first, you are welcome to. So there you go. Only the x squared moves, and we're good. So here, if we want to reduce, 4 divided by 2 is just 2. Now, this one right here, the y is being raised to the negative third, and the y is being raised to the negative 1. So it's negative 3 minus a negative 1. So that is a negative 3 plus 1, or negative 2. The answer always goes to the top. Right, so this is what we have now. The 2 is not being raised, the 2 stays on top, but this one's going to move to the bottom. This takes practice. Practice makes perfect. So try these out. Give yourself a second, and just do your best. So do the math, and then get rid of the negatives. Okay, just to clarify, I did the distributing first, and now I am going to get rid of the negatives. So here I have a fraction. I just distributed everything in. Z squared does not have a negative exponent, so that stays on the top. But these two do, so those move to the bottom. And you can leave the 1, put the 1, doesn't matter. Same deal with this one. Everything's in the top right now. This one is in the wrong place. The other two are good. Okay. All right, try these. How you do them is up to you. Let's see how we do. Okay, so I almost finished them both. This one here, I got x to the 9th over y squared. Just remember when you subtract here, it's 5 minus a negative 4. So that's 5 plus 4, which is 9. And here this is negative 4 minus a negative 2. That's negative 4 plus 2, which is negative 2. So that negative 2 means that the y belongs in the bottom. So notice what I did here. This can get a little confusing when you're dealing with numbers, so I just want to point this out. When you're distributing your outside exponent in, you need to put them on the numbers also. So 3 to the negative third power, you put that in your calculator, it's 1 over 27. That can be messed up, confusing. So what I like to do is I distribute my exponents to my numbers, and then I move my numbers and only deal with them when they're positive exponents, because I get confused. Well, actually I don't, but so that one guy needs to move. So that n to the 6th, m to the 9th stays there. They're both positive now that I distributed that negative in. This 3 to the negative third should be down here, make it a positive 3. And that 2 to the negative 3 on the bottom moves to the top. Now that I've done that, I can see that that's just an 8. And this one's 27. I just do that to make my life a little easier. All right. If I can also do something like this where I simplify each of the following and write the answer without a denominator. So that just means I'm going to put things in the wrong place, I guess, or make it so that they don't have a denominator. Shocking. All right, so I'll simplify here first. The x's go away. Subtract the exponents here. 1, this is y to the negative 2 power. That's it. That doesn't have a denominator. The denominator is not, I don't know what I'm doing there. The denominator is like a 1. So now it doesn't have a denominator. This one here, I can reduce the 4 and the 8. It's 1 over 2. A to the third power. I don't know what that is. So this is a denominator. They're both in the denominator, so a way I can change that is just take these and move them up. So you can either just do 2a to the third and just raise them all to the negative 1 power, or you can give each one of them a negative exponent. So I just simply want to move it up. I kind of ran out of space here, so let me just, I can't erase now. Forget it. All right, here we are. This one, 12 divided by 2 is 6. The x's go away, and when I subtract 1 minus 2, I get y to the negative 1. There's no exponents. There's no denominator, so I'm done. Here, there's a denominator, a to the negative third. Now, it is in the wrong place. It's negative, so when I move it up, I do that. So a to the third is your answer. So here, I mean, you can do the subtraction with the a's if you want, but a to the 0 power is 1. But 0 minus a negative 1, that is a to the first power. And then negative 3 minus a negative 3, that's 0. So those, anything divided by itself is 1 anyway. So we're just left with 3/8 to the first power. Here on this last one, we have, wow, that's really big. Let's just do this then. 15 divided by 3 is 5. This is what I like to do. I do the math, and then if there's a denominator, I move it up, or I follow whatever rules that they have. So I'm doing this, negative 2 minus 1. I get negative 3, so that's x to the negative 3 power. And then 2 minus 5, that's a negative 3. Again, everything is in the top. I'm good. Have a good one.